All right, let's get started. Get started. So today we learn about n root and rational exponents. Unit 8 is on, okay, Unit 6 we learn about some arithmetic power, right? The number, all the number. Unit 7 we learn about all polynomial. Unit 8 we kind of combine these two. We also learn about the power and also about the inverse function, domain and range. So we kind of combine these two as well. So not really like completely new topic. The only main thing we learn today is this. I'm gonna write in red, actually better. The only thing we learn today, and we're gonna just do all the example about this thing is here. You're gonna start seeing something, fraction on the power. Okay, but don't be freak out. I know that you don't like fraction, but when the fraction on the power, it's actually very easy. See what is equal to. Okay, ready? When you see the fraction on the power, what it means is the top number is the power of x. Okay, let me write it. You want to convert this. This will be the power. So power m. The bottom number. So top is the power. Let's write down first. Top is the power. And the bottom number is the power of the root. The power of the root. So you're going to have root right here. Let me make this inside. Okay. It's going to be the power of the root. Like that. So the top is the power and the bottom is the root. And if you want to memorize this, this is how I think. The top, the ending letter is P, so the starting letter of power is also P. So it should remind you the top is the power. The power means the power of the number, like this. And the bottom number is the root. We're gonna do some examples so you can know what is it about. So this is two way of represents the fraction of the fraction when the fraction is power. When the fraction is the power. This presentation they call exponent notation. Okay, and this notation they call radical notation. Yeah, that's it. That's the only way, the only thing. That is the only thing we're gonna learn today. That's the only thing we learn today. So whenever you see the fraction on the fraction on the power, that means the top one is the power. The bottom one is the root. It's the root power of the radical. You're gonna have some not only square root, but cube root, 4 root, 5th root, 6th root. You're going to higher levels, not only square root. There's a good news and bad news. What one you want to hear first? Bad news is this lesson we have 5 parts. 5 parts. The good news is only 2 examples for each part. Like very short part. But it just means like 5 different way of the question you're gonna see, but they only same topic. It's a very short lesson on each part. Okay. So part 1 is when they ask you to rewrite the expressions using maybe radical first. Exponent. Let's do exponent first. Exponent notation. So that means you're gonna rewrite. You're gonna convert the radical into fraction. For example, if I give you square root of x, how can you maybe cube root of x? Can you convert this one into exponent notation? We're gonna do together, okay? All right, let's do together. We're gonna pause a little bit. All right, anyway. Yeah, okay. So you're gonna convert this radical notation into exponent notation. Okay, how can we do this? All right, first I write out the x first. Okay, what is the power of x? What is the power of x right here? 1. There's no power, that means invisible 1, right? So 1. Okay, 1 on the top, 1 is the numerical. I mean numerator. So invisible 1. Okay, what is the power of the root? 3, cube root, right? So 3. Where 3 going to go? On the bottom, yes. So this in the bottom. Yeah, so that's it. That's the main new knowledge that we're gonna learn today. X power of 1/3. So now you know what does it mean when you see the fraction of the power? That means there is some root. Square root, cube root, or root, we don't know, but there's some root over there. Okay. Any question for this? You good? Okay. All right. How about this? Yeah, we're gonna start using it again. Long time we haven't used it. So okay, selenite. All right. What convert this into exponent notation? 7, 1/4. Yeah. There's no power, that means invisible 1. So there's 1. And then the root power is 4. So the bottom is 4. 7, 1, 1, 4. Very good. This is my 7. If you don't see it. Okay. Invisible 1. And then 4 is the bottom. Good. So we're gonna do some couple, and we move the couple of the assemble, and we move to the part 2. All right. Number 3. Rodaplobe plata. Again. Just go inside first. Okay, you're gonna do inside first. So 9, right? 1/3. Very good. See, the more you just do like the third assemble, you can already like figure it out. Like it's in your mind right now. So 1, and then the root power is 3, so 1/3, 1/3, 1/3. Then you still have the square. What can you do with a square? Remember this, unit 6? Did you multiply them or you add them? Multiply. You multiply them. So 1/3 times 2, which is 9/2. Okay, that's the answer. Yeah. I think when we work with the number, it's easier. Easier than we work with the graph. All right, next, Nayeli. Let me know if I need to slow down something. You're gonna want me to slow so you can write down the notes. Okay, number 4.
1, 7.
And still have the cube, right? So what is it equal to? Times 3, yeah. You multiply them. So what is that? 3 over 7, right? 1 times 3 over 7. Yeah. The note right here, I'm gonna ask you. Are we done with number 4? Yeah, let's take the time to write down. Okay. Think about first. Are they different or the same? I want you to think about that first. I have cube root of -8, but a square outside, and I have did I write the same thing?
Yeah.
Oh, so they are the same. All right. You know the last period of wait, is it last period? Yeah, you're the last period. So my mind is already on the children mode. All right. The same. I don't care. I'm just kidding. Oh, it's on recording. All right. Do you think they are the same or they are different?
They're different.
Why are they different?
Because the two is outside, and then the
Right.
bottom is
So 1, 2 outside, 1, 2 inside. But why they are different? Why? I know they look different, right? One outside, one inside. But why they are different?
the parentheses.
Right. Because remember, the square outside always give you what? What kind of number? Negative number or positive number? Yeah, the square outside always give you positive number. Yeah. Let's do one by one. You will see. Cube root of -8 is cube root of -8. What is cube root of 8? Oh, good. Let's go over this. What is cube root of 8? Okay. We're gonna find what is cube root of 8. Okay. Can you break down the 8? 4 and 2. Can you break down the 4? The number outside of the roots gonna tell you how many same number you're looking for in order to the number to get out of the root. Right? So how many number we're looking for? How many same number we're looking for? 3. Do we have enough 3? Yes, we have 3 same number 2, right? So they're gonna go out. Yeah. So maybe you can write a note too. Maybe we didn't mention this. Okay. So the number outside, the root power indicates how many same number needed to get out of root. Okay, so the root power indicates how many same number is needed. Is needed to get out of the root. So maybe write down the sample is cube root of 8. Maybe that help you. The 4 root, how many same number we're looking for? For 4 root, 4, yeah. And 5th root, you need to get 5 same number. Yeah, you got the idea. Yeah. So what is cube root of -8? Huh?
2.
It's a -2, -2, -2, right? -2 times -2 is -8. Correct?
Yeah.
-2 times -2 times -2 is -8. So 3 same number. Yes, I'm looking for 3 same numbers. So this is -2. Yeah. So here this is -2. And you still have the square on the top. So what is it equal to? +4 or -4? +4. Very good. You're good. At least that's the one that you can get out of this class. Like everything when you square it, you're gonna have positive. How about the number? No, the second one. What do you need to do first? You need to get inside the square root first.
Yeah.
Right? So what is -8 squared?
64.
64 or -64? Positive or negative? Who say positive? What would you confident yourself? Maybe they're wrong, maybe only you right, yeah? Who say it's a -64? You raise your hand too? Okay. Good. It's a negative. Remember, without the parenthesis, it's still negative. Remember when we talked about this like in beginning of class? Like this, yeah? this one is 4, but this one is -4. Remember? Because the square only applies to the number. So 2 square is 4 and you still have the negative. But this one, the square applies to the negative as well. So that you have -2 times -2, that's why you have 4. So this is -64. Now, what is the cube root of -64? 4. -4. Yeah, -4. Like cube root of -8 is -2. Cube root of -4 is cube root of -64 is -4. -4 times -4 times -4 is -64. So that's why they are different. They are totally different. Two, one positive, one negative. So work inside first. You can write out work inside first. Okay, work inside first. Okay, write this. Yeah. All right. Okay, so that's the part one. See, one part is not long. So part two is, what do you guess? The first one I asked you to convert to exponent. So the second one is what? What do you think? I will ask you to convert back to the radical. Okay, like back and forth using radical notation. Number 5. Excuse me. Thank you. This is allergy seasons. All right, number 5. All right, let's see who next. Anthony. Not here. Oh, here, yeah. Anthony, okay. So you see the exponent notation, you know, now give me back the radical notation, like something like this, right? With the radical. What are you gonna do? First, just write a number with the radical first, okay? And now you're gonna fill in the number. Where is the top goal? Your power,
Yeah.
right? So power 1, but you don't really need to write the power 1, right? So this is 1 divisible 1. Where the 2 go?
It's gonna go on the bottom. It's gonna go on me.
Where does it go over here?
Bottom root.
That's the root.
Yeah, bottom root. Well,
So the bottom is the root.
Yeah.
So it's going to be the root power right here. So it's going to be 2 right here. Right? But here's the thing. When you see no number outside, what does it mean? Is that square root, cube root, 4 root, 5th root, what? If you don't see any number, what does it mean? Square root, right? So if you don't see any number, that means there is invisible 2. So there is invisible 2 right here. Because it is square root, right? So same thing, if you see 2, you don't really need to write it 2 because, so the answer should be square root 3. Again, invisible 1, you don't need to write the power 1, that's not necessary. And then 2, when you don't have any number, they automatically know that this is square root. So you don't need to write 2 as well. So this is the answer. Well, if you keep this, it's still fine. That, yeah, it's still fine. It's just that we don't need to write it. We automatically know that no number means square root. Because that's how we say it, square root. Okay. So now you know that the power 1/2 actually is equal to square root. Yeah. So what is, just on the side, just what is 9 1/2? 9 to the power 1/2, what is it equal to? 3. Good. 3. Right? Power 1/2 is just square root. Because here, power 1/2 is just square root. So 9 to the power 1/2 is square root of 9, and that is 3. Yeah. So power 1/2 means square root. So how about power 1/3? How about what power to 1/3? How about if I have like 8 to 1/3? What does it mean? What is it equal to? 2. Yeah. Because 1/3 is mean cube root, right? The power 1 go to 1, and then the bottom is the root power, and the cube root of 8 is 2. We just did it. The cube root of 8 is 2. We just did it. So power 1/3 is cube root, power 1/2 is square root, and so forth. All right, next person, Timara. 3 to the power 7/10. So write it using the radical notation like this. I want something like this happen. So you want to write the radical 3 first, yeah? And then you want to fill a number. What number?
For the outside, you put 10.
Okay, so 7 inside, right? 7, so the power is 7, yes, good, inside. And then 10 outside, 10 is the root. So 10 roots of 3 to the power 7, yeah. So this is the answer. Very good. Easy, right? Good. Can I erase this? Okay. Right, number 7. The last one for this part. See, very fast. Only 5 part, but very fast. Okay. Just more practice. Maria,
Yeah.
just keep writing and just said, yeah, you're right. You said, yes, you're right. 3 outside, right? Yes, 3 outside and 4 inside. Okay. The reason why I give this a sample, because, okay, when you see the direction is rewrite, you don't need to go all the way to the end. Okay, you just rewrite it. This is the final answer, but I want to link this one to the next part. Next part is when I ask you to evaluate. What does mean when it's evaluate? So that you need to get all the way to the end. For example, this, if I ask you to evaluate, you need to give me more. What does it mean more? Because you can still do it more. How many same number are you looking for to get out the root? 3, right? Do you think I have enough? Yeah. 12 to the 4, that means 12 times 12 times 12 times 12, right? That is it? 12 to the 4 power, that means 12 times 12 times 12 times 12. Do you agree? Yeah? Right? So that's why I just break it down. How many same number looking for again? 3. Do I have enough 3? Yes. So 3 of them. 3 of them are going to go out. So I have 12 going to go out of the cube root. Do I have anything inside? Do I have anything inside? Yeah, I want to have left over number 12. So 12 gonna stay inside cube root like this. Yeah. And I don't think we can do anything else for this. Let's say 12 is 4 times 3, and 4 is 2 and 2. Yeah, there's no 3 same number. So this is the final answer. If I ask you evaluate, you're gonna stop right here. If I just ask you to rewrite, you're gonna stop right here. Does it make sense? Yeah. Yeah? Okay, good. So that link to the next part. See, this part only 3%. Next part is evaluate. Evaluate the expression. Without using calculator. Oh, this is without. Just my notation for without. Without using calculator. Right, numbers 8.
Well, you get 2000.
You got 2,000.
Oh, that's a good way of thinking. It's a good way of practice. Okay. Leave it alone. Back here, number 8. Next person, Brian. Yeah, here. So, the question is evaluate. Okay. You need to give me the final answer. But when you look at the fraction, it's kind of not familiar, right? So how about you convert it into radical, make it more familiar? Yeah, it's fine. But yeah, but write in radical first in case like you don't get familiar with this. You convert them. It's going to be square root of 25, and the answer is fine. But if again, like Brian, that he know the answer, you can just go directly to 5. Yeah. Again, 1/2 is square root. 1 cube is cube root. Good. All right, next person, Chris. Chris, can you do this one? 64 1/3. Okay. All right, that's good. I'm gonna rewrite what he wrote in right there. Okay, what is it equal to? Evaluate that means you need to get the answer. What is the cube root of 64? 4. I feel like we back to like silent movie, you know, like Chaplin. Look at him to do it, like copy it. And you know Chaplin? Charlie Chaplin? Oh yeah. He like a legend. The silent movie, but he make like yeah, number 4. So it is 4, yes. Okay. Number 9. Hayden. Square root, very good. Square. The root of 9 power 3. What is it equal to? Did you get to the answer? So what is it equal to? Huh? Just work one by one. It's not, I don't think it's 3 though. Is it 3? No. Okay. When there's no number, that means it is square, right? So square, that means how many same number you're looking for? 2. So 9 cube, that means you have how many number of 9? 3. Do you have enough 2 to get out? Yes. So 2 of them, they're gonna get out. So I have 9. And what do I have left? Another 9. Right? Can I stop right here? No, because square root of 9, you can still do it, right? Evaluate again. Evaluate means you need to go all the way to the end. Oh. So 9, square root of 9 is 3. 9 times 3 is 27. That would be the final answer. See? From here, I don't think you can get to here in one shot. So I think you need to get to convert them to radical and then you work one by one. Question? Number 9. Yes. So I convert this one into radical form. The power 1, the top number is the power, so this is the power 1. And then the bottom number is the root power, right? The bottom number here is the root power. And then 64, you're gonna break the 64, okay? 64 is what? What 2 number multiply 64? 8. 8 and 8, okay? 8 and 8. And then can you break the 8? 4. 4 and 2. Can you break the 8? 4. 4 and 2. Can you break the 4? 2. 2, 2. Can you break the 4? 2, 2. Okay? How many same number you can for? 3. So, okay, 3, this one 3. They're going to go out. I have 3. I have 2. And then I have another 3 right here. Right? Another 3 same number right here. So they're going to go out again. It's 2. So then I have nothing left. 2 times 2 is 4. That's That's one way. You can also break this one into 16 and 16 and 4, right? And then 16 is 4 and 4. You can break this like this too. And then you have 3 same number 4, so that is 4. Faster, if you can see it. Instead of breaking 8 and 8, I break into 16 and 4. And then 16 is 4 times 4. I have 3 same number 4 as well. Or you just know that 64 is a perfect cube. Do you remember the word perfect square? Yeah, you remember that? What number is perfect square? Can you remind me? What number is perfect square? 4, 9, 9, right? 3 square is 9, 16, 25, 36,
100.
yeah, 100, 49, 64, 81, right? So this is 7 square, 8 square, 9 square, and 10 square. And perfect cube is what? 1, 8. 8 is 2 cube. 81 is 3 cube. 3 cube. No, 3 cube is 27, actually 27. I think 27. And then 4 cube is 64. That's 4 cube. You just know it. And then 5 cube is 125, and so on. Yeah. Just the more you do it, the more you know it. And then any question for number 10? Are we going at 10? Yeah? All right. I will try to delete the lesson early. But I think if you, this is not hard, and I just want you to get used to all type of questions. I give you the homework because the other period I have some student when we still have like 30 minutes left, and yesterday is a short day, right? We still have 30 minutes left, and they just finished the homework in class. You only have 1 page of the homework. Only 1 page, and they just finish in 30 minutes. So maybe you can finish in class and you don't have anything to do at home. So maybe we can try that. Number 11.
For the same part or different part?
It's same part. It's still on part 3, right? It's on part 3. The evaluation part. Evaluate. Too many questions. So that's all for the part 3. Part 4 is very short, and then part 5 is solving. It's a review. So
We're doing all 5 parts today.
yeah, 5 parts. But it's short. Yesterday is short day, but they all finished like 30 minutes before the class ends. So don't worry. Okay, next question, Mark. 11. What is cube root of negative 27? Why do you have 1/3? Oh, you convert them to this? Like 1/3?
Yeah.
Well, we don't need to because we want to evaluate. That means you need to give the number. This is the way that we have been familiar. So don't convert to this. This is, yeah. You don't need to convert this. And I think I just said that 27 is perfect cube. So what is cube root of 27? 3, right? You can try, if you don't see it, you can try to break it. 27 is 3 and 9, and 9 is 3 and 3. So I'm looking for 3 same number, right? Because number is cube root. So 3 same number, so negative, actually negative. So it's a negative 3. We will talk about a negative inside square root. Have anyone like had a question in your mind from the beginning until now? Mister, you said we can never have the negative inside square root, but you keep having the negative inside square root. What happened? Have anyone wondering about that? Yeah. This we cannot solve this unless we have some imaginary. We need to use the imaginary system, right, to handle this. But this one we can handle this. What is the difference between this and this? This is square root. This is cube root. So the point is, whenever you see the power of the root is even, you cannot do it unless you need to use the imaginary system. But we're not going to talk about imaginary in this unit. But for when the root power is odd, is suppose symbol is cube, then you can have it. Does it make sense? So I'm saying it again. You are allowed to have the negative inside square root, not square root. You are allowed to have the negative inside the root if the power of the root is 3. It's odd. But you don't allow to have negative inside the root when the power of the root is even. Yeah? Does it make sense? I will write down, don't worry, I will write down. Hello? Okay. So, yeah. We're recording, so don't worry. Have fun, enjoy.
Yeah.
All right. Jennifer. We will talk about this, don't worry. The next part we're going to talk about this. So don't worry about this for now. I just want to read anyone that have that question in your mind. All right, Jennifer, number 12. 32 to the power negative 2/5. Let's convert them. Let's convert to the radical form. It's easy to see, right? So 32 radical. What number go where? So you have negative 2/5. How do we handle the negative power? All right, let's do it together. Let's do it together. Do you remember how we handle the negative? How? How we handle the negative power? Oh, we should have a pop quiz. No one remember? What we're gonna do? Like I think you all remember, but you cannot show. You like just give the side signal. Obviously, is it correct? Yeah. What you doing correct? We're gonna flip it. You're gonna flip it. Remember, if you see the negative and you want to make it positive, you need to flip it. So this is on the top. You flip it to bottom. Is it bottom? You lift to the top. Thank you. Oh, thank you. So 32 2/5. Yeah, that's how you make it positive. Do you remember? Yeah. Okay, so in this kind of question, you need to handle the negative first. Okay. Handle negative first. All right, handle the negative first. So you have this. Now Jennifer, you can finish this. Where 2 go and where the 5 go? Where does 2 go? Where does the 5 go? 2 gonna go inside and 5 gonna go outside, right? Yes. So the 5th root of 32. Oh, okay. Now work on this. You cannot stop right here, right? Let's work over here. Let's work on this. You cannot stop here. And remember the question when I ask you is doing without a calculator. You're gonna tell me, oh, Mr. It's 32 squared. How can I do without a calculator? No, you don't need calculator. You don't. You're gonna see why. So 32 squared, what does it mean? Is that 32 times 32, right? That's squared. Are we good with this? Yeah? 32 square is 32 times 32. Yeah. So we still got it here, right? All right. Now can you break the 32 for me? 16 and 2. All right. So same thing here, 16 and 2. And then 16, can you break the 16 for me? 4 and 4. Good. Same thing here, 4 and 4. All right. Don't break more because you already see the same number. But how many same number are you looking for? 5. I have 1, 2, 3, 4. What else? Do I have enough 5? No. But what do I have left? 2 and 2, right? I have left 2 and 2. What is 2 times 2? 4. So I have another 4 here. It's hidden here. 2 times 2 is 4. So how many 4 I have right now? 1, 2, 3, 4, 5. Can I get out? Yes, right? I need 5 same number to get out. And now I have enough 5. So 1, 2, 3, 4, 5. So this actually equal to 4. See that? Let me go. Let me know if you want me to go over again. Yeah? Okay, let me go. Okay. Here. Let's go one by one, okay? So negative, I flip it to make it positive first. So negative, I flip it, become positive. Okay. Now work on this. 32 square. Square means 32 times 32, right? So I break it down to 2 set of 32. And then 32, I break it down, I have 16 times 2. 16 times 2 is 32. And then same thing here on 40, 32 as well. And then 16 is 4 times 4. Same thing, 16 here, 4 times 4. Now, the root power is 5. So looking for 5 same number. I count. Okay, I have 1, 2, 3, 4. I only have 4 number 4. But what I have left is I have 2 and 2 left. But 2 times 2 is 4. So I have enough 5 of number 4 to get out. Yeah? Okay. You still need to get the answer here. 1 over 4. Because this is false 1 over 4.
Wait, so what's the answer now?
That one you work on the square root, and this one is the final answer because you have 1 on the top. You get it? 1 over this, and then this equal to 4. So you have 1 over 4. All right, next. Sophia Epson. Alan. Number 13.
134.
Huh?
134.
125. Oh, okay. Let's work on that. So this is 8, this is 7. Yeah. How many same number are you looking for? Oh, 7. 25 to the 8. I will just break like this. I will just break to the power 7 and to the power 1. Yeah? Did you get here? 8 is, I break it down to 7 and 1. I don't need to write 25, 25, 25, 25, 25. I don't want to write that. Yeah? Because the reason I break to 7 because I see that, oh, this is 7. 7 same number looking for. So do I have enough 7 number? Right here, right? So this 7 number of 25, they're going to go out. So 25. What do I have left? 25. 25, but this is what? 7 root. Oh, so your answer is not correct. Yeah, because 7 root, not square root. You know what? I know why you got 25, 125. But here, this is 7 root. 7 root of 25, nothing happened. So this is your answer. 25, 7 root of 25. How do you think about this unit 8 so far? Not too bad, right? Not too bad. Yeah. Hopefully. Maybe. We have a lot of lesson for the A. If you look at the step sheet, you can see A, B, C, D, E, F, G, I, H, I, something. Because we combine arithmetic from unit 6 and function for unit 7.
Is that 7 the base root or is it the square root? For the answer.
The 7 is for the root power, the power of the root. So, I think a lot of you confused. You always call this one square root. This one is not square root. It's a the root, but because When there's no number, they call square root. But when there's a number, that you cannot call square root. It's a cube root, 4 root, 5th root, 6th root. This one by itself is radical. They call radical. Yeah. Are we with number 13? So far so good? Still alive? Yeah. Okay, no. Jose. 14. Flip, very good. Take care of the negative first. So flip 36 power 3 half. Okay, what next?
36
Mm-hmm.
to the 36 square.
36 square? Where the top number going to?
Yeah.
It's 3, right? Yeah. And then where's the 2 going? That's the root power. Okay, that's the root power. So that's the square root. Do I need to write 2? Do you need to write number 2 here? No, you don't need to. Just square root. When there's no number, then no, that's a square root. Now, what is square root of 36? We need to do it.
6.
No. How about you? You want to have like 10 seconds to try it? Or 30 seconds? Let's try it. Try to give me the answer for this. What is the square root of 36 to the cube power, to the third power? Do it. Break it and give me the answer. How many same number you looking for? 2.
6. Wait, no, I know, brother.
Oh, he answered how many same number? Yeah. Did you get the answer? Let's try by yourself. That's what you need to do. Yes, exactly. That's good job. That's what you need to do. You're looking for 2 same numbers, so you're gonna break it into. Yeah, just remember to take the half class.
Yeah.
Try by yourself first. That's the hint. That's the hint. Because I'm looking for 2 same number, so I'm gonna break it into 36 square and 36. So try by yourself first.
Oh, is good.
The one on the top. So we got, yeah, it could be 1 over whatever you got. Yeah. What did you get? What did you get for this? What did you get? Did anyone got the answer? $2.16 is correct. If you got $2.16, it's correct. Did you get $2.16? Okay. How do you get $2.16?
Use the 36 in square root, so use the 36, we have 136, so square root of 36, and then square root of 36, take 36 and 6 here.
Exactly. Yeah, but it's a big kind of fast. So let me write what he said. But exactly what he said. How many same number we're looking for? 2, right? I break this one cube into 2 and 1. And do I have enough 2 numbers to get out? Yeah, 36, right? So this one go out. 36. What do I have left inside? 36 I have left inside. This one left inside, right? And what is square root of 36? 6, right? So here, let me erase this. So this equal to 36 times 6, right? Square root of 36 is 6. 36 times 6 is 216. So that's how Maria got 216.
What is this?
So the answer is 1 over 216. Yeah?
So, like, what happens to this, to the,
Here? Or here?
the 2, what happens to the 2? On bottom.
Here? Oh, I'm looking for 2 same number to go out,
Yeah.
right? And this one square, that mean there's 2 same number. So this go out.
Oh.
Yeah, that's go out. Yeah. Similar to this, I'm looking for same number, so I just bracket to 7. Like you know, it faster if you just bracket the same number you have here. Yeah, visible. Because when you don't have any number, that means automatically that is square root, that is 2. So 2 same number. Yeah. Like square root of 9, you don't write any number 2, right? So that's automatic 2. Okay, last example for this part. Elizabeth, yeah. So cube root of negative 27, negative 3, right? And negative 3 square is so easy with this. Yeah. Cube root of negative 27 is negative 3, and negative 3 is your weight 9. When you work with the cube, you will memorize this number like 27, 64. You will see that.
We're adding three times three times three, three times three times three, and three.
3 times 3 times 3, yes. 2 times 3, 37. Part 4. Find the indicate real and root of A. Number what? Okay, 16.
So what you ask me, real?
Real.
Real?
Real. Yeah. Yeah. Forgot to move this. All right. Right. These questions, you will see this question on homework, so that's why I want to go over it. This question basically it's a little bracket. So they give you n and a, n root of a, and then they give you what is the number of n and what is the number of a, and you bracket it. So basically you bracket it. You know what is your answer? 4, right? You plug it in. Okay, here we go. Oh, n is 2. Okay, so this is 2. A is 16. So 16. Square root of 16 is 4. Good. Yeah, that's it. Yeah. So I give you this. And then I give you what the number of n, what is the number of a, and just plug it in. Like the n root of a, I give you n equal to 2, you plug it in n is 2. I give you a is 16, you plug it in n 16, and you find what is the answer. So square root of 16 is 4. Yeah. That's the 4 part. This part we're gonna talk about the negative inside square root and the cube root. All right, what is this? Krisha, can you tell me what to write? So where the 3 going? Outside, and where the a going? Yeah, inside. What is the cube root of negative 64? Negative 4. Negative 4. Good. Good. That's it. All right. Let's see who lucky for this one. Oh, Yasmin. You're very lucky because this one is tricky. All right, Yasmin. Let me know when you're ready. So You don't need to put the score, you just need to put it if they exactly the same check mark, right? You didn't have the same for the next. Because when I see you check mark, I will just give it. All right, Yasmin, ready? All right. What do I put number 4? Outside, very good. What do I put number in negative 81? All right. What is it equal to? Ah, that is a tricky one. You say negative 9? Okay, negative 9. No, don't write yet, okay? That means you say negative 9 times negative 9 times negative 9 times negative 9. Are they going to give you 81? No. Okay, that's 3. So you're saying negative 3 times negative 3 times negative 3 times negative 3. It's going to give you a negative 81. Okay, let's see. Negative 2 times negative 3 is 9. This is 9. So 9 times 9 is 81. Not negative 81. So what happened? What happened? Plus minus. That's great. What do you think? Huh? Imaginary? Well, yeah, but we don't want to deal with imaginary in this unit. So no solution. So here the note is it is impossible to have negative inside when the root power is even. For the negative, for the odd power, it's okay. The odd power is okay. But the even number is not okay. It actually is an I. You got it right, it's an I. But this unit, we don't want to use the imaginary system. So just put the solution. But yeah, I know. That's why I said you're lucky. But if you wrote an I, I still give you full point. If yeah. So here the note is I will write a note for you. It's impossible to have even root power and negative number. Okay. Okay. I said specifically in the direction is real. So I don't want something imaginary. That's why I put it real. Indicate real. So that's why you're gonna have no real solution. To be more precise, no real solution. No real solution. Because you're gonna use imaginary.
Oh, I kind of the screen. Actually, it wasn't 10 minutes.
Last part. We go to the end. Solve the equation.
No, we were going 20 minutes. Oh, 5 minutes?
19.
What is it?
We want that. Oh, okay. You gonna rest it? Okay. No, she said no, but she like, no, go ahead. Like she like that, like no, go ahead. Only yeah, only this, and then we done. Okay, that would be it.
Is that gonna be on the?
Yeah. I go over 5 different type of questions because they will be in the homework. All right. Samantha. Let's do number 19. This is review. We already learned this. What you gonna do? Yeah, you're gonna take the square root both sides. Very good. Because square root and square they cancel out. You have x equal to what is square root of 25? Is that my final answer? Plus minus. Yeah. Just remember whenever you see x, whenever you see letter, you take the square root, you need to have plus and minus. Because when you see x, that means you need to solve it. When you solve it, you need to have plus and minus. Orlando, number 20. What do you need to do first? Square. Why? You need to solve for x. You need to get rid of everything until you have x at the end. Divided by 2 first. You need to divide by 2 first. You get rid of this 2. So 16 divided by 2 is 8. Now what you do next, Orlando? Continue. How can I get rid of the cube power? Cube root. You take in the cube root. Okay. If you want to get rid of the square, you take in square root. If you want to get rid of the cube, you need to take the cube root. Because cube root and the cube they cancel out. So this cancel out, you have x. What is the cube root of 8? 2. Good. Do I have plus and minus here? Who say yes? Who say no? Answer is no. That's another thing we need to know. What is negative 5 squared? 25. So that's why you have plus and minus. What is negative 2 cubed? Negative 2 cubed. It's negative 8. It's not 8. So the point I make here is you only apply plus and minus when the power is even. Okay? Only apply plus minus for even power, for even root power. I know it's kind of confused with the odd power and the even power. Just know that everything is the same for the odd power. They're only a special case when you have even power. Because even power that turns every number into positive. Even negative number, when you have even power, is turned to positive. So that's why only apply plus and minus for even root power, because 5 squared 25. Negative 5 squared is also 25. But for the odd power, 2 cube is 8, but negative 2 cube is negative 8, not 8. So you only need one solution. So long story short, you only apply the plus and minus when the power is even. Okay. Andrea, second to the last example. What do you do? Who can help her? Distribute?
We get rid of what parentheses.
You get rid of parentheses? Yes. How did you get rid of it?
X plus 3.
Okay, if you want to get rid of the parentheses, you need to get rid of 4, right? You need to get rid of the 4. How can I get rid of 4? 4 root, not 4 square root. 4 root. You take in the 4 root. Right? Take in the 4 root. Take in the 4 root, you cancel those 4. Yeah. So x minus 3. What is the 4 root of 81? What is the 4 root of 81? Let's do it together, okay? 81, what are two numbers multiplied to 81? 9. And what is 3? What is 3? What is 9? 3 and 3. You know, when you might have the answer, you kind of say it. 9 is 3 and 3. How many same number are you looking for? 4. Do we have enough to 4?
Yeah.
Yeah, so this is equal to 4. This is equal to 4. Is it correct? Is it? Do I miss anything? Do I miss anything? Plus and minus.
Plus minus 3.
4 is even. 4 is even number. I must have plus and minus. Yeah. The other, I think the other period as student, there was a student told me to plus 3 right here. Why didn't I plus 3 right here? This whole term they 4, they to the power of 4, this whole thing. So you cannot, you can only plus 3 when the 4 only apply to x, and you want to get rid of negative 3. In this case, everything is 4, so you need to get rid of 4 by 4 root. It's different. So here, what are we going to do next after this? There are two different answers because I have positive 3 and negative 3. Let me rewrite it two different cases so you can see it clearly. Right. How can I get rid of negative 3? Plus 3, right? Yeah? Correct? Yeah. So this one cancel out. What is 3 plus 3? All right, for this case, what is negative 3 plus 3? Negative 3 plus 3. 0. Any question? Let me know. Yeah. Question? Question. So I got, okay, again, I'm taking the 4 root to cancel the 4 power. And 4 root of 81 is 3, okay? But because this is even power, I apply plus and minus for even root power. So this is even, 4 is even. So that's why I have plus and minus. And because plus and minus, that means I have two solutions, two different solutions. So I wrote them separately to see. So x minus 3 is positive 3, and x minus 3 is negative 3, like this. And because I want to solve for x, I need to cancel the negative 3. I plus 3 on both sides. So 3 plus 3 is 6, and then negative 3 plus 3 is 0. Yeah? Any questions? What part confused? Here or here? Here? Are we good? Are we good? Any question? Ask me, okay? Can we move on? 32? Go Blope. Who did I call? Did I call you already? Okay, so yeah. So this one is Montano. All right. What are you gonna do? How can you get rid of the fifth root? Fifth power. You're taking the root, yeah, fifth root. So fifth root and the fifth power, they're gonna cancel out. So x equal to, what is the fifth root of negative 32? So 32 is 16 times 2, right? And 16 is 4 times 4. And 4 is 2 times 2. 4 is 2 times 2. Okay, I know that I'm gonna looking for 5 same number. 1, 2, 3, 4, 5. Oh, so this is enough 5. So I have negative 2 because there's a negative. Yeah? So this is negative 2. Do we have plus and minus? Why? Because it's odd. This is not even. Yes, because it's odd. You got it now. Yes, very good. Very good. Okay, last one. Last one. And you want to have. Oh, we basically go one round already. Saturday. So what are you gonna do? Subtract 4 first. Very good. See, this one 4 doesn't have power. So you're gonna get rid of 4 first. Minus 4. So we have 3x fifth. 37 minus 4 is 33. One next. So then finish it. Divide by 3. Very good. So x fifth. 33 divided by 3 is 11. Now how can I get rid of the fifth power? That's fifth root. Taking the fifth root. Cancel this. I have x equal to. Can we do anything with the fifth root? 11? No, huh? 11 we cannot bracket. So just keep it the same. 11 fifth root. And do I have plus minus here?
No.
No, because
There's no.
it's odd. It's odd. That's it. Congratulations. You went through the first lesson of Unit A. It's kind of long, but it's not that hard.